Summer is one of the best seasons for e-bike riding. The days are longer, the weather is better, and there are simply more reasons to get out and ride. But summer is also the time when many riders decide to upgrade their e-bikes, and that's exactly when mistakes start to happen. Choosing the wrong e-bike kit can completely change your riding experience, and not in a good way. So in this video, we're going to talk about the most common mistakes people make when choosing an e-bike kit for summer, and more importantly, how to avoid them. Varstrom recently launched a summer promotion, offering an 8% discount on orders of €300 or equivalent value on Varstrom.com for 10 days only. The video is a bit long, but hopefully it will dispel some misconceptions you may have about upgrading your e-bike. Many riders believe that a higher wattage automatically means a better upgrade. 750 watts sounds powerful, and it is. But power alone doesn't tell the full story. The real question is, who are you, and how do you ride? Are you commuting daily in the city? Are you upgrading an older kit to something more modern and efficient? Or are you building a cargo setup that needs more torque and load capacity? Different riders, different scenarios, different needs. Let's break it down by real-world scenarios and rider profiles. Starting with 250 to 350 watts, this range is ideal for flat, paved city commuting. It's best suited for casual riders, lightweight riders, or those who still want a fitness-oriented riding feel. Why choose this range? Because it offers higher efficiency, longer battery range, lighter overall bike weight, and lower cost if you mainly ride in urban environments without steep hills. This is often more than enough. Next, 500 watts, the all-rounder. This is ideal for mixed terrain, moderate hills, and daily commuting. It suits the average rider who wants a balance between power and battery life. You get sufficient torque to handle inclines without draining your battery too quickly. For many riders, 500 watts hits the sweet spot. Now we move into 750 to 1000 watts. This range is built for steep hills, off-road trails, or hauling heavy cargo. It's especially suitable for heavier riders, commuters in hilly areas, or off-road enthusiasts. The key advantage here is torque, stronger acceleration from a stop, and superior climbing ability under load. When choosing wattage, consider these 4 key factors. First, terrain. Flat cities require less power. Steep hills, sand, or mud require higher torque, usually 750 watts or more. Second, rider weight and cargo. Heavier riders or cargo setups typically need at least 500 to 750 watts to maintain consistent performance. Third, battery life and efficiency. Higher wattage motors drain batteries faster. A 250 watt system will generally give you more range per charge. Fourth, legal regulations. In many European countries, the limit is 250 watts, while in places like the United States it can go up to 750 watts. Higher power systems such as 1000 watts are often used for off-road riding, steep terrain, heavy cargo, or performance builds. And remember, higher wattage doesn't mean you always use full power. Most e-bike systems allow adjustable assist levels so you can ride efficiently and only use extra power when needed. When choosing a battery for an e-bike conversion kit, the 3 most crucial steps are matching the motor voltage, calculating the capacity based on range requirements, and confirming battery mounting compatibility with the frame. First, matching the voltage, the motor's thrust. The battery voltage must be strictly matched to the controller and motor specifications of the conversion kit. Higher voltage generally means faster speed and better climbing ability. 36 volt, most common in entry-level or lightweight urban commuter kits, suitable for flat roads. 48 volt, the mainstream choice for conversion kits, offering the best performance to weight balance, suitable for most hilly terrain and medium to long distance riding. 52 volt, an upgrade option for enthusiasts, providing stronger instantaneous power and higher top speed than 48 volts, but you need to first confirm controller compatibility. Second, calculating capacity WH, your tank size. The total energy of a battery is measured in watt-hours, calculated as voltage V times ampere-hour equals watt-hour. This is the most accurate metric for range estimation. On average, a modified e-bike consumes approximately 20 to 25 Wh per mile on flat roads. Capacity selection recommendations. 300 to 500 watt-hours, suitable for short urban commutes under 15 miles. 500 to 750 watt-hours, the balance point for most riders, suitable for mixed terrain riding of 25 to 45 miles. 750 watt-hours and above, suitable for long-distance touring, heavy load freight, or steep mountain challenges. Want to estimate how far your battery can take you? At Varstrom, we provide a simple formula to help you calculate battery range based on your setup. First, check your motor's rated speed. You can find it in the product core data of each conversion kit. For throttle mode, voltage multiply by capacity divide by motor power multiply by related speed. For pause mode, 2 multiply by voltage multiply by capacity divide by motor power multiply by related speed. For example, if you use a 36-volt 24-amp-hour battery with a 36-volt 250-watt motor. Throttle mode, 36 multiplied by 24 divided by 250 multiplied by 25 equals about 85 kilometers. Pause mode, 2 multiplied by 36 multiplied by 24 divided by 250 multiplied by 25 equals about 160 kilometers. Of course, actual range also depends on terrain, rider weight, and riding style. We've compiled a reference list of the battery cell brands and models commonly used in batteries available on the market. Every Every Varstrom battery uses a custom BMS design for our conversion kits. It supports 30 amps continuous discharge with 90 amps overcurrent protection. If you use your own battery, just make sure the discharge current stays below 30 amps, and for safety, every BMS includes overcurrent, overvoltage, overload, overcharge, overdischarge, temperature control, short circuit protection, plus voltage balancing. Every Varstrom battery comes with a charger included in the package. The charger is not an optional accessory, it is already included and matched to the battery voltage. For 36-volt batteries, available chargers include 42-volt 2-amp, 42-volt 3-amp, and 42-volt 4-amp. For 48-volt batteries, chargers include 54.6-volt 2-amp, 54.6-volt 3-amp, and 54.4-amp versions. For 52-volt batteries, chargers include 58.8-volt 3-amp and 58.8-volt 4-amp. If you want to estimate charging time, Varstrom uses a simple formula: battery capacity divided by charger current, then add 2 hours. For example, charging a 24-amp-hour battery with a 4-amp charger. 24 divided by 4 equals 6, plus 2, so the estimated charging time is about 8 hours. Actual charging time may vary slightly depending on battery condition and remaining power. Before purchasing an e-bike conversion kit, the most crucial step is ensuring the kit is compatible with your existing bike's physical specifications and assessing its structural strength. First, consider the following safety and performance issues. Regarding your bike's frame material, steel or aluminum alloy frames are best suited for modifications. We do not recommend installing high-power motors on carbon fiber frames because carbon fiber cannot withstand localized high torsional stress. Then, consider your braking system. Upgraded bicycles are faster and heavier. Disc brakes are recommended for better braking performance. If the original bike has V-brakes, choose V-brake rim options. You need to confirm derailleur compatibility. For a rear-wheel motor, confirm whether the motor supports your existing gear setup, whether it's a freewheel or a cassette, as they are not interchangeable. Then there's the torque arm. For motors with a power output exceeding 500 watts, you need to consider adding a torque arm to prevent the huge torque of the motor shaft from breaking the fork or the gear shift point of the frame. Next are the key measurement parameters. Before placing your order, be sure to measure the following parts of your bike. If you plan to purchase a hub motor, you need to measure the frame over lock nut dimension spacing. For a front hub motor, the standard width is typically 100 mm. For a rear hub motor, city bikes typically have 130 mm. Mountain bikes have 135 mm. Snow bikes or wide tire bikes may require 170 to 190 mm. If you plan to install a mid-drive motor, you will typically need a standard bottom bracket with a width between 68 mm and 73 mm. Press-fit bottom brackets may not be directly compatible. Confirm your wheel size, for example, 26-inch, 27.5-inch, 29-inch, or 700C. The motor wheels in the aftermarket kit must be compatible. Finally, you'll need to measure the available space for the battery. Besides electrical compatibility such as voltage, continuous discharge rating, and connector type, the physical fit of the battery is just as important. If you want to buy a rear rack battery, it's important to make sure your bike rack has enough space and compatibility for installation. Let's use the Varstrom rear rack battery as an example. First, measure the usable flat length of your rear rack, as the Varstrom battery is 476 mm long, so your rack needs enough straight mounting space to support it securely. Next, measure the distance between the front crossbar of the rack and your seat stay, and make sure there is at least about 195 mm of clearance to prevent the battery from touching the seat tube during installation. Then check the vertical clearance between the rack and the rear wheel or fender, since the battery height is about 89 mm, ensuring there is enough space to avoid contact with the tire or mudguard. The rack should also have a flat mounting plate area, and for the Varstrom rack back battery system, the mounting plate height is approximately 86 mm, so your rack should be able to support this base properly. Because different racks have different widths, and the battery frame is about 165 mm wide, make sure the overlock nut dimension, including the mounting bolts, is close to 165 mm, allowing the battery mounting rail to sit flat and centered on the rack structure. You should also check the mounting hole spacing on your rack plate, where the slots typically allow about 10 mm of adjustment with roughly 36 mm to the lower mounting point, ensuring the bolts can align with the mounting holes. In addition, confirm the rack load capacity, as rear rack batteries add extra weight, so the rack should be rated for at least 25 kilograms for safe riding. Finally, check for possible interference with rear fenders, brake cables, or pannier mounts, since some racks designed for cargo bags may require adjustment to fit the battery properly. For a downtube battery, start by measuring the length and height of the front triangle of your bike frame, usually around the bottle cage area. For example, using a Halong battery, allow 78 mm of clearance from the upper hole to the top of the battery, and 226 mm from the lower hole to the bottom of the battery. The minimum distance between the two holes is 34 mm, and the maximum is 90 mm. If there are pre-existing holes or no pre-existing holes, an additional adapter can be used to install the battery on bicycle frames without standard water bottle cage holes, where the mounting position can be adjusted for better fit. Measure an additional 15 to 40 mm of clearance beyond the battery's actual length to ensure you have enough room to remove it from the cradle. With pedal clearance, ensure the battery width does not interfere with your legs or the crank arms while pedaling. In addition to the actual length of the battery, consider whether the battery thickness interferes with the top tube and C-tube. A Helio battery with a top thickness of 106mm and requires an additional 15mm clearance to ensure smooth removal from the bracket. For installing your e-bike display, there are a few things to check. First, measure your handlebar diameter. If there is a small size difference, you can usually fix it by adding a spacer or shim. Next, make sure there is enough space near the stem so the screen is easy to see and operate while riding. Then check the cable length and connector type to ensure it reaches the controller smoothly. If the cable is too short, you may need to install an extension cable. And finally, confirm the communication protocol, UART or CAN bus, to ensure the display is compatible with your motor. Another common mistake is choosing a group set solely based on price. While a lower price can be tempting, the most important question is whether the group set truly matches your riding needs. In summer, people often ride longer distances and more frequently, which can place higher demands on your e-bike setup. Some riders may need a larger battery capacity for extended range, while others may require more motor power for climbing hills or carrying cargo. If the configuration doesn't match your riding style or typical riding conditions, you may end up upgrading or replacing components later. Instead of focusing only on price, it's better to consider how and where you plan to ride, as well as your expected riding distance and terrain. Choosing a configuration that fits your actual needs will provide a better riding experience from the very beginning. Reminder! Our summer sale is underway, giving you the opportunity to purchase a more powerful EBikeconversion group set at unbelievable prices. Want to know more? Just Google Varstrom and check us out. Follow us on social media, join the conversation, and share your Varstrom story.